Welcome back. This is Nick Graham. I will be discussing the binomial expansion, which is a preliminary or a prerequisite when you're going to study more about counting techniques and binomial theorem and everything about probability. And to start with, the sum a plus b is called a binomial as it contains two terms. Okay, we have monomial, binomial, trinomial, and polynomials. An expression of the form a plus b parentheses raised to n is called the power of a binomial. Okay, so for example now, if we simplify this, we have a plus b raised to 0. We know all numbers raised to 0 is equal to 1. And then we have a plus b raised to 1 is the same as a plus b. And then we have a plus b raised to 2. This is a quadratic. Then we have a squared plus 2ab plus b squared. Okay? And then we have a plus b raised to 3. This only means that we have a plus b multiplied by a plus b squared. And a plus b squared is a squared plus 2ab plus b squared. And then we have a raised to 3 plus 2a squared b plus ab squared, if I'm going to multiply a to all the terms in the second parenthesis. And then we have b now. We have a squared b plus, this is also positive, and then we have 2ab squared plus b raised to 3. Simplify, we have a raised to 3 plus 3a squared b plus 3ab squared plus b raised to 3. Okay? And then if we have a, here, another pen maybe, a plus b raised to 4 is the same as a plus b squared, a plus b parenthesis squared. And if we expand those, we have a squared plus 2ab plus b squared squared, actually. And then if we multiply, so we have, if I'm going to remove that so that you can see, then I will write here a squared plus 2ab plus b squared. So if we multiply, we have a sub 4, a raised to 4, and then we have plus 2a raised to 3b plus a squared b squared. That's the first term, first part for this one. And then we have 2a raised to 3, 2a raised to 3 b plus 4a raised to 2 b raised to 2, and then 2a b raised to 3. And then the last one, we have a squared b squared plus 2a b raised to 3 plus b raised to 4. We simplify that, then we have a raised to 4 plus 4a raised to 3 b plus 6a squared b squared plus 4ab raised to 3 plus b raised to 4. So if I'm going to put just the coefficients, the constant coefficient for this, for the first, we have, going to use another pen. For the first coefficient, we have 1 there, and then we have 1, 1. We have coefficient 1 there and 1 there. and then they have 1, 2, 1 for this one. 1, 2, 1, and then we have 1, 3, 3, 1, 1, 3, 3, 1, and then we have 1, 4, 6, 4, 1. So we have 1, 4, 6, 4, 1 there. This is called now the Pascal triangle, this one, called the Pascal triangle. Okay, if we will continue, then of course how to continue, as you can see here, if you add those, and if you add those, if you add those, okay, and then add, and always the first and the last is always 1. Okay, just the second term or the middle terms which give you the idea, the different coefficients. Okay, those are the constants. What more we can say is that, for example here, as you can see, the exponent, maybe I can see here, the exponent of a starts from the n, and then it will become 2 minus 1 or n minus 1. Whereas b starts with 0, as you can see here, b raised to 0 is that, and then 1 was that, and then you have the n here. Okay, here also is n minus 1, and then n here. Okay, here it is n minus 2. Okay. And then if you have 3 here, now we have 3, 2, 1, and then 0 there. Okay, here is, I forgot to tell you here, it is 2 minus 2 here. That means raised to 0 or n minus 2. Okay, so it decreased by 1, but b increased by 1. Okay, those are the things that we can read here. Okay, here is the summary. For the expansion of a plus b parentheses raised to n, where n is a natural number. Okay, as we look from left to right across expansion, the powers of a decreased by 1, while the power of b increased by 1. The sum of the powers of a and b in each term of the expansion is always n. If we go back here, our exponent is 2, so we have 2 here, we have also 2 here, we have also 2 here. We have 3 here, we have 3 exponents, and the powers. Okay. And the number of terms in the expansion is n plus 1. So if we go back here, you can see that our n is 0, and our term is 1. Our n is 1, our terms are 2. And then we have n is 2, then we have 3 terms, n is 3, we have 4 terms, n is 4, we have 5 terms. Okay, it's good to know those things. The coefficients of the terms are rho n of Pascal's triangle. So I've seen a while ago, I've shown you a while ago. Maybe it's better with another. We have 1, and then 1, 1, 1, 2, 1, 1, 3, 3, 1, and then 1, 4, 6, 1, 4, 1, and then 1, 5, 10, 5, 10, 10, 5, 1, and then we have 1, 6, 15, 20, 15, 6, 1. This is the 0, 1, 2, 3, 4, 5, 6, and so on. Okay? Let's take some examples. Okay, using a plus b raised to 3, parenthesis raised to 3, we multiplied already that. Find the binomial expansion of 2x plus 3 parenthesis raised to 3. So we have our a is 2x, our b is 3. So we're going to use, this is our a, question A. Then we have 2x plus 3 raised to 3 is the same as our a raised to 3, that is 2x raised to 3, plus 3 times a, that's 2x, times r raised to 2, times b, that's 3, plus 3 times our a is 2x, times b squared, that is 3 raised to 2, plus b, which is 3 raised to 3. Simplify, we have 8x raised to 3 plus, this is now 2 raised to 2, that's 4 times 3, that is 12x raised to 2. Oh, sorry. We have, I forgot some more. I will stay here. 9 times 4x squared. This one is 4x squared. 3 times 3 is 9. And then we have 6x multiplied by 9 plus 27. And then we have 8x raised to 3 plus 36x squared plus 9 times 6, 54, x plus 27. Okay? Yeah, how about the b? We have the b. We have x minus 5 raised to 3. Then we have x raised to 3 plus 3 times a, that's x, times b, that x squared, times b is negative 5, plus we have 3 times x, that's our a, and then we have negative 5 squared, plus negative 5 raised to 3. Simplify, we have negative 15 x squared, and then we have, that's 25, we have 75x, and then we have negative 125. Simplify some more, we have x squared, x raised to 3, that's wrong, x raised to 3 minus 15x squared plus 75x minus 125. Okay, more examples. Find the fifth row of the Pascal triangle. So we've seen that we have 1, I will put it here, 1, and then 1, 1, 1, 2, 1, 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. That is the fifth row. This is a plus b raised to 5. And then if we put the variables, then this is a raised to 5 plus 5a raised to 4b plus 10a raised to 3b squared plus 10a raised to 2b, and then we have plus 5a b raised to 4, and then the last term will be b raised to 5. Okay, so we've done a already. And then we have find a binomial expansion of x minus 2 divided by x, parenthesis raised to 5. So our a is x, our b is negative 2 divided by x. So if we are going to simplify that, then we have x minus 2 divided by x raised to 5, parenthesis raised to 5. Then we have x raised to 5, that is our a, and then plus 5 multiplied by x raised to 4 multiplied by b, our b is negative 2 divided by x, plus we have 10 multiplied by x raised to 3, and then we have negative 2 divided by x raised to 2, plus we have 10 multiplied by x raised to 2 multiplied by negative 2 divided by x raised to 3, plus 5 multiplied by x multiplied by negative 2 divided by x raised to 4, plus we have negative x divided by 2 raised to 5. Simplify, we have x raised to 5 plus 5 times negative 2 is negative 10 multiplied by x raised to 3, and then plus we have now 10 times x raised to 3 multiplied by 4 divided by x squared. I am just simplifying, plus 10 multiplied by x squared multiplied by, I have negative 8 divided by x raised to 3 plus 5x multiplied by, not negatives, that's 16, only 16 divided by x raised to 4, and then we have negative. I see, I've done wrong here. It should be negative 2 x. And then we have negative 32 divided by x raised to 5. Okay, simplify some more. X raised to 5, and then we have minus 10 x raised to 3, and then this one now we have 40 plus 40 x plus we have minus is that minus 80 and divided by x, and then we have 16 times 5, that's also 40, no, that's 80, 16 times 5 is 80 divided by x raised to 3 minus 3 there, 32 divided by x raised to 5. I will stay there for a while. I will stop there. It's almost 20 minutes. And in my next video, I will give you more examples how to deal with Pascal triangle. And I hope that you like my presentation, and thank you for watching. Please subscribe and or donate. Have a nice day. See you soon.